And so that's pretty much the end of what I wanted to talk about, other than just opening up for discussion and getting people's sort of comments on how viable or useful you think this kind of architecture is, what VM should we be looking at, and another thing is scenarios to evaluate whether or not this is a good idea.
Story first about protection.
Story about protection.
Yeah, like one VM from checking out the isolation.
You're safe. Both sides are safe.
I mean, both sides are safe. I mean, so you have to know, there's no protection against VM bugs in a common process, right? If you're in the same address space, you can whack each other. And that's the reality of managed runtime today, right? You load a native method, you're not safe anymore. So, Doug.
So you realize, of course, that what you presented is isomorphic to the isolates API from JSR 133, except that 121. Except that you couch it in the form of different languages. So could you implement isolates, separate VMs, and then you'd have to think about your protection story a little bit harder.
Okay.
It sounds like an orthogonal problem, right? One, you're trying to create an isolation domain, and another, you're actually trying to bridge communication between different object models and so on.
But still, you have all the ingredients, and the different thing is that when you do the marshalling, you're going to have to think really hard about how you do it. In Parley, in an isolates, there's no requirement that you think hard, but there's nothing preventing you from doing so.
Actually, so you could look at app domains inside the CLR. That's their mechanism for isolation at least. But I was going to ask about things that might cross the call stack, like the security model. You know, if you're using stack-based security, how does it work if you cross
Well,
VMs?
So we have an API for basically letting. We require VMs to implement an API to let you crawl their stack frames. And so whatever mechanisms were being implemented in the library to do stack inspection would still continue to work.
So you trust the other VM then to do the right thing?
I mean, you have to. This isn't a. So we're assuming that VMs are not hostile to each other. Otherwise, putting them in the same address space is a disaster. So this is you've got some. This is all part of the same application that's running. It just happens to be written in 5 different languages. So there's no.
Just out of curiosity, because this is oddly enough, this is a solved problem. The Perl folks have been doing this with a bunch of languages for 3 or 4 years now. Have you taken a look at the inline series of modules that come with Perl that do interop between Perl and Python and Ruby and Java, and if you really want to get wacky, and C and Defunge, because someone did it as a joke. But it just fires up in this case, since it's from the Perl end of things, fires up a Perl interpreter and dynamically loads in the other VMs, executes code in them, and they pass routines and subroutines and objects and calls back and forth transparently. To the point where you can write some of your Perl code in Java and some of it in Python and some of it in Ruby, and all just make calls to those functions and invoke those object methods in your Perl code as if they were Perl.
So what's the performance then? A normal.
It's just a normal, and the only performance that you pay is you pay the cost of making making a call to an external function in Perl plus whatever an invocation is on the foreign VM end. And I think the Python people have got a variant. There was a big inline spate a couple of years back. So do the same thing. Python will let you.
I don't know the details underneath, but isn't there proxy generation as a result of that?
What ends up happening is, they look in each other's innards and find out what functions have been invoked and expose things back and forth. But I mean, once everything's all set up, it just works.
So look at the performance characteristics.
Yeah, I would assume there's no shared services among the VMs, so
yeah, I mean, it's not necessarily what you're looking for, but I mean, in the case where the VMs are only loosely coupled in the same process, doing that.
So I mean, I think part of what we're trying to do is scenarios where the boundary crossing is going to happen a lot.
So
I'd definitely like to talk to you.
would garbage collection work in your scenario?
Well, in our
With
scenario,
ref-
all the languages involved are reference counted garbage, or reference count garbage collection. So what ends up happening is when an object goes away, you know, when the Perl handle on something goes away, its destructor gets called and it gives up the handle on the foreign object, and presumably then at that point, if its reference count goes to 0, then it does its thing.
You can have cycles that just keep them running forever, I guess.
Oh, sure, you can have cycles that'll keep things up forever, but that's no difference from any other cycle in a reference count.
So when you do things within one process, you pretty much have to have the same address space restrictions for both. Say one is 32, the other is 32. 32-bit, the other is also 32-bit. So have you thought about, because I think there might be a lot of interesting cases where at Intel we have been doing some work where we are trying to load 32-bit libraries, IE32 libraries into a 64-bit VM and be able to do emulation, which is a dynamic translation, all within the same process. And I think with sort of a lot of movement to both 32 and 64-bit, a lot of interoperation across those might actually be pretty interesting, which doesn't seem to get addressed in a single process model somehow. And then the other question that I had was that how do you sort of handle signals? Because each VM has sort of lots of internal internal assumptions which don't get exposed in any kind of modular fashion. And how do you really handle those? And that doesn't seem like a very...
For signal handling,
That's a
what we're
problem
basically
today.
assuming is that...
It's a problem today.
You load a JVM into any other real application, it will interfere with that real application, guaranteed, because the signal handling is so abusive.
Right,
So,
but when you
I mean,
put
it's-
two
it's a-
VMs together,
Add two
it
VMs,
sort of
twice
like
as
compounds
bad.
the problem 10 times.
Yeah,
I'd go for square, 2, 4, 8,
Yeah, I mean, what we're
16, excuse me.
What we're planning on doing is basically the VMs get to register interest in, we've been mostly thinking about the sort of trap instructions and segmentation faults. And for those, you get to register, okay, this is, if a trap happens in this IP range, this range of code, then I'm the VM that wants to handle it. So Parlay catches the signals and then redirects them to VMs that are registered interest in particular address range. Now, if someone's doing a timer interrupt or some other signal, then that's less clear what to do with it. And so we've been assuming that the VMs are relatively embeddable, and that may be naive. But that's the, you know, if all they want to do is capture traps that happen at a well-defined IP that's part of their generated JIT code or their actual VM space, then we can deal with that. If they're random signals going off like timer interrupts, then you got to do something, but we don't know what yet.
Yeah, that's a problem we have to solve anyway, right?
Right, I mean, if you want to embed these things in different applications, it has to be solved.
So we'll take one last question, but I also want to ask people whether there are any topics they want to suggest from both this talk and the previous talk, Ben's talk, to add to our list of topics for discussion later. So think about that, and Mark.
I was wondering if people, you talked about the Perl interoperability layer. I wonder if we could, and you mentioned that all those used reference counting GC. So I don't think reference counting GC works very well in a language like Java. Is there any reason we can't replace what's in Perl and Python, et cetera, with what I think of as a real GC?
Believe me, for whatever it's worth, I mean, for the next generation of Perl, we're switching over to a real GC. The one problem that we run into is the one thing you get with a reference counting GC is you get deterministic destruction.
Yes.
And regardless of how much you end up paying for it and how many edge cases you don't actually really get deterministic destruction because you actually have a reference hanging around that you might not know about, and how many cycles of garbage you might have, attempting to tell people that they're not going to get deterministic destruction usually brings out the pitchforks and torches.
Does the Perl problem finalize where you can notice the difference?
Mark, I think I'm going to cut out the discussion if you don't mind. We're
Yes,
starting
we
to
can
eat
talk
to the
about
next
this later.
talk here. Perhaps you guys can take that offline. Let's take 1 minute to see if anyone has any suggestions or questions on this talk or the previous one before we move on to the next talk here. Anyone had a topic that you wanted to
One discussion item from Ben's talk obviously was what's the right programming model for chip SMPs?
Concurrency.
Or do you even
concurrency
need a
in
new
general.
one?
Yeah.
Right.
Yeah.